Hello class. This is going to be the first video in the Algebra 2 Honors Final Review series. I don't know how many it's going to take, but we'll just see how far we get today. Okay, now, like I said, I'm going to show you how to do everything that you can do on Desmos and or a graphing calculator, but I'm also going to be filling in the blanks for the knowledge along the way. For example, what does it mean for a function to be even? Well, what it means algebraically is that if you replace your x with a negative x, when you do all your simplifications, absolutely nothing will change. The way that that will happen is if every x that has an exponent, actually I shouldn't even say that, everything that has an x has to have an even exponent on that x. So this doesn't have an x, so I don't have to worry about it. That does have an even exponent. There's going to be your answer. But look, odd exponent, odd exponent, odd exponent, odd exponent, odd exponent, odd exponent. This one only has one that's even possible. So if you put a negative x right here and then square it, you get back to positive x. So you end up with this exact same answer. But what does that look like geometrically? Well, this is reflecting over the y-axis. So every even function will look something like this. Or, I mean, maybe like this. But they're going to be reflections of each other over the y-axis. So if you were to type this equation into Desmos, you'll see that half of it's on the left side of the y-axis, the other half is on the right-hand side. 3x squared plus 5, in fact, let me just demonstrate, 3x squared plus 5. Boom, there you go. As you can see, half and half, okay? All right, back to... where the freak is the camera? Here it is. Number 2. So what does it mean to be odd? Algebraically, it means if you replace your x with a negative x, after you've done all the simplifying, it'll look like you distributed a negative 1. How does that happen when you're talking about the exponent trick like I did for evens? Well, it's a little bit more challenging. So for even functions, you just need all of your exponents to be even powers. For odd functions, you need all of your exponents to be odd numbers, but you also need no vertical shifting. So anything that ends with a constant automatically eliminates that answer choice. The reason why is because all odd functions are symmetric around the origin, meaning if you spin the thing a half a circle, then you get the exact same picture around the origin. So it could look like that, or it could look something like this, but they have to be symmetric around the origin, where if you spin half a circle, you get the exact same picture. You see, I mean, I know the rest of the image is upside down, but this is the exact same graph that I had before I spun it. So that's how you do it algebraically, geometrically, and the tricks. No vertical shifting because they have to be symmetric around the origin, and the vertical shift would mess that up. And all of your exponents need to be odd. This is causing a problem. Therefore, the answer is this one, and I will graph it on Desmos just to prove that point. Come on, Desmos. We got negative 5x, where'd it go? No, negative 3x to the third. By the way, I used the caret symbol, shift 6 got me that exponent up there. And then I had to hit over to get out of the exponent position, minus 5x. And let's see, that doesn't really look good, so we'll stretch it out to really highlight what's happening. See, spin this thing around the origin, half a circle, this branch lands right on this branch, and there you have it, okay? Boop, home, all right, back to, where's my camera? Here it is, back to the images, or away from the images, I should say. A tech startup can express its profit P by this formula, a negative quadratic, where X represents the average price they charge per software license. What must the average price per charge per software license be to maximize their profit? Okay, well there's the key, right? This is a negative quadratic. It's going to look like this. And where does price maximize? Right here at the vertex. So all we have to do is go to Desmos, type this in, and ask for the x value of this, because it says what must the average price be, and average price is what x represents. So we just need to figure out what x value is our axis of symmetry. Now I could use the formula x equals negative b over 2a, which, I might as well do it. It's going to get me negative 60 over 2 times negative 1. And you'll have access to a calculator, but this is 60 over 2. The negatives cancel, so the answer is 30. But let's go ahead and go to Desmos just to double check. I'll show you how to do everything on Desmos. No reason to use the graphing calculator unless you have to. We have negative x squared, and then plus 60x, and then minus 200. Now you'll see you can't see this vertex, but if you scroll out, zoom out, oof, I'm hitting shift and then I'm scrolling some more. That's squishing the y-axis. Click on the graph and click there. You can see it's at 30, 700. But you have to be careful. You needed to look for the x value only. And the reason why I said be careful is because when we go back, 700 was one of the options. This is the maximum profit. This is the price per charge. Okay. Number 4. A manufacturer can express its total expenses. Okay, so this was profits, this is expenses. Using this formula, a positive quadratic, where x represents the number of units produced. What number of units produced will minimize their expenses? Well, it literally is talking about x's again, so we're looking for a minimum this time. It's the exact same setup. X equals negative b over 2a, which is going to be negative 40, got to be careful, over 2. Which gives you 40 over 2, or 20. But just in case you don't want to remember the formula or can't remember the formula, you can just go to Desmos. Once again, you just need to know that you're checking for the x, because this says what number of units. If it had said what's the minimum expenses, then you would have chosen the y value. But let's go ahead and type it. X squared minus 40x plus 500. Sheesh, where'd you go? Okay, well, I can't see it, so I got to zoom out, zoom out, zoom out, zoom out, zoom out. Where are you at? Oh, here it is. Click, click. X equals 20, but you watch out, because this is one of the answer choices also, but you were searching for x's, okay? Wink. All right, back to the camera. Use the graph of g of x, which is the what looks like skinnier one, to identify the transformation from f of x. Identify the value of k that is appropriate. Okay. Well, you don't have an equation for this, which is going to make it harder for you to use Desmos. What you could do is you could basically make up your own f of x and then put k places and see if it gets you the kind of picture that you see here. I'm going to go ahead and tell you what I mean by that in just a second, but I'll describe what's happening here. Anytime you see addition or subtraction, and it doesn't matter if it's inside or outside, this is going to be a shift. And because this graph did not move anywhere, these are instantly bad answer choices. That leaves us with these two options, and they're the same kind of transformation. They're a multiplication, and they're both a multiplication on the outside, meaning not inside the parentheses. Multiplication on the outside is you changing your y values. Remember I said a minute ago it looks skinny? That's because it's not skinnier. It's technically taller. Imagine if you didn't change your weight at all, but you put on platforms. The extra height gives you the illusion of skinniness, and that's what's happening here. G of x appears skinnier because it's actually taller. So what would make a y value bigger? Well, another thing you could do is you could pick any pretty point that the original function goes through. Here's a pretty point. And here's its corresponding pretty value. And notice that it used to be at what we can say is y equals 1 and is now at 1, 2, 3, 4. So that's you multiplying your y values by 4. Now let's say you forgot how transformations work. What could you do? You could make up a function, one that looks like this parabola right here. It would be best if you used something like y equals x squared. There's our f of x. Okay, so I'm going to go to x squared on Desmos, and we're just going to put things places. So we get x squared. Oops. Your option for option A was replace x with x plus k in parentheses. So what I'm going to do is I'm going to open a set of parentheses where x was and replace it with x plus 4 to see if it gave me a picture like this. Let's see, where is the Desmos? Parentheses x plus 4. Okay, that's wildly wrong. That didn't do it. What if the plus 4 was on the outside? Okay, back to Desmos. So that means you just have x squared and then plus 4. That didn't get us the image that we saw. What if we did a 4 on the front of x squared? A graph that looks skinnier. Done. That's the proof that the answer is C. And just in case you wanted to know, if you had done D and you put a 1/4 on the front, be careful. The original one is the black one. This red one did not get quote unquote skinnier, it got wider. Therefore, like I said, we've proven that the answer was C. And that was just by making up a quadratic. Makes it look wider. It's actually a shorter graph, but it makes it look wider. Here's your first 5 down. Let's see. Oh, that's right. It's single-sided because our copier was no freaking good. This is the same kind of question. It says, use the graph of g of x, which is this new one, which is a transformation of the absolute value of x. So you could go to Desmos, and you could literally type in all of these options until you got a picture like this. Again, I think it's faster to just know how transformations work. So how do they work? Any addition or subtraction, inside or outside, doesn't matter, is a shift. So the question is, what happened to the parent vertex to make it land here? Let's talk about the up-down first, because I think that's the easiest. Because outside changes always do exactly what they look like they do. This vertex went up 2. And that's why on the outside, vertical, outside of the structure, same effect will be a plus 2. So you need k to be plus 2. That instantly eliminates those two options. Now the only question is it a 1 in here or a minus 1 in here? And these are really tricky. This is really, really tricky. So here's what I want to do. I want to go to Desmos, and this is either going to say x minus 1 or x minus negative 1. It's going to say one of those two. Okay, so let's go to Desmos to see what it is. The absolute value bar, if you're looking for it, is directly below your backspace key. You have to hit shift though to make it work. So we don't know if it's going to say x plus 1 absolute value bar, and then what did we say k was 2? Or is it going to be absolute value x minus 1 absolute value bar plus 2? The original one is just absolute value of x. And there's a lot of colors going on here, but I'm hoping you can see that the green one is like the image on the review packet, and the green one, so not blue, the green one should say x minus 1. Should say x minus 1. Well, there's already a minus sign there, so that means h would just be the value 1. Just like that. The way it works is horizontal transformations, things that happen on the inside, always have the opposite effect as they look like. So this minus 1 actually has the same result as adding 1 to the x's, which is why it shifted to the right. Complete the sentence to make a statement that best describes the graph of f of x plus 8. Okay, now this is an inside change. This is an inside change. Horizontal changes happen on the inside and they have the opposite effect as what they look like. The horizontal axis is left-right. Therefore, opposite of plus would be minus, would be left, 8 units. But again, let's say you forgot, just pick a function, just pick one. Stay away from y equals x. Don't do that, okay? So let's go to Desmos. I'm staying away from y equals x. How about y equals x to the second power? Or even, let's do absolute value x again. Shift x, shift, there. And what it did is it put x plus 8 on the inside of the structure. Just to remind you, I'm talking about, see how this means where there used to be an x, now there's an x plus 8. So on Desmos, I've just chosen a random equation, and where I had an x, I'm going to type in x plus 8, and what you're going to see is it definitely went to the left. Okay? So we're going to use Desmos in every way that we can to cheese this thing to get a 100%. Okay? There you go. Wait a minute. Did I say to the right? Oh my gosh. My golly, I hope as soon as I said to the right, somebody was like, you're wrong, you said opposite, plus means right, so you're supposed to go to the left, ding-a-ling. It's the opposite of what it looks like. It looks like move to the right, that's why it goes left. Man, I swear I'm smart. I promise I'm smart. Number 8, complete the sentence to make a statement that best describes the graph. You know what? Let's just go directly to Desmos. Let's take our absolute x and let's subtract 1 and see what happened to it. Because, again, leaning on Desmos. See your graph? Here's minus 1. Looks like it went down to me. Down by 1. Okay. So down. Boop. Number 9. Man, look at that. They're really trying to trick us. You know what I would do for this question? I wouldn't solve anything at all. You've got Desmos on your side. Pretend this is the x-axis. What we need is a dotted line, because that's what the open dot means, and we need the x-axis shaded to the right. And all we have to do is type these answer choices on Desmos and see which one matches. First of all, let's think smarter, not harder. You see how this is an open dot? That means you can't have equal to. So this answer is impossible and this answer is impossible. All we need to do now is type these two things on Desmos and see which one works. We'll type the first one. Actually, you guys can see them just like I can. So when I go to Desmos, shift that bar, remember it's underneath the backspace, x plus 2, close it, not equals, sorry, less than, which is right above the Alt key on the right hand side of the bottom keyboard, x minus 4, zoom out, that's weird. It would appear as though that question has absolutely no answers. That can't be it. So let's get rid of it, and let's see, hopefully that last one works. Absolute, x minus 2, absolute, is less than x plus 4, bingo, there we go. So imagine open dot, shaded to the right. See that part of the x-axis is colored. So we know that the answer is D. Think it's smarter, not harder. Not trying to actually solve these things. You give me Desmos? Shoot, I'm using Desmos, folks. Number 10, same exact kind of question, but this time it's a closed dot, which means it has the equal to bar. So anything without the equal to bar is impossible. Now we just need to type those two and see which one it is. And the really nice thing is there's one difference between them. One has a plus between the x and the 8, and one has a minus. So I'll do example B first. We're looking for a solid, and then it'll look like this. With all the shading to the right. That way that part of the x-axis is covered up. All right, absolute x, what was the first one? Plus 8, absolute, and then greater than or equal to 6 minus x. So the greater than is where the period is, so shift, and then hit equals, and it'll put the equal to bar for you, 6 minus x. That's pretty convincing, but we need to know at what value. You see that's happening at x equals -1. And if you look at your answer choices, your graph, it actually starts at x equals -2. So that can't be the answer. Now let me do example, or answer choice C, where all that happens is that plus becomes a minus. And it looks like the answer for that one is all real solutions. So guess what? This is a bad question. It was intended to be that one. And the question is just wrong. That's really funny. Okay, well, the one on the final had better not have that kind of mistake. I did not write this final review, so this is not my fault. But this should have been right here. But we're going to go ahead and say that that's the answer choice that they were expecting because, well, it's the closest one. Because it's a solid dot. That's as good as it gets. So what was that one, B? We're going to say B is the quote-unquote answer. And I'm even going to, you can't, here, let me show you my air quotes. It's the answer. That number's wrong, but that's the right picture. So we'll go with this one, but we're going to say bad question. I'll have to let the person know who wrote it. Let's see. We've been doing this almost 20 minutes. How many questions are in this packet? Maybe I'll do it in 4 videos. 46, 4 videos, 12. Okay, let's get 12 questions done. What is the solution to the system? Your options are work hard and do the algebra, or go to Desmos and type it and see what you get. So I'm going to go to Desmos, and I'm going to type it and see what I get. Go to Desmos. This first one says 2x plus y equals 4. And the second one says 3x plus 2y equals 1. And zoom out. Looks to me like the answer is down here somewhere. Click, click, 7, negative 10. Go back to home. 7, negative 10 is answer B. There it is. How could you have had no solutions? If the lines were parallel, there would be no solutions. They would never intersect. So how can you have infinitely many solutions? If the lines are the exact same line, Desmos will only show you one because they're laying on top of each other. And I'll show you how to confirm that that has happened already. And by the way, I can already see that the answer is B. How do I know? Because I see that if I take this top equation and I divide by -3, see how I got this over -3? I get this equation here. So when one is a multiple of the other, the answer is there's infinitely many solutions, but I just want to show you what that looks like on Desmos. That way you know how to be on the lookout for it. So we go to Desmos, and that's where we'll conclude this video. We have 2x minus 3y equals 6. Then on the next line, -2, fraction bar is actually the question mark on the keyboard. So bottom right next to the shift, you just hit that question mark key, that's your fraction. And you type 3, and then over the right arrow. Then x plus y equals -2. And it looks like Desmos only graphed one line, but if you toggle this one on and off, you can see the colors changing. That's how you know they're the exact same line. The purple's just laying on top of the green. So there it is, infinitely many solutions, like I said, and that's how you recognize it. Our answer was B, and I feel like that's a fantastic place to stop the video before we all fall asleep, and we'll try to get 12 more done in the next video. Thank you so much. You're awesome, nerds. Keep up the hard work.